ma'am from the other aspect that I am her PhD student. So, and this is my pleasure to welcome you, ma'am. So, today's session conduction will be done by Dr. Sriporna Saha. So, over to Sriporna, ma'am.
Very good morning to our respected speaker, Professor Niyogi ma'am, and good morning to our HOD ma'am, and good morning to all the attendees present over here. So welcome you once again on the 5-day online faculty development program on application of AI, ML and DL in smart healthcare. This particular program is being sponsored by AICTE Training and Learning Auto. So we are now on the day 3 and session 2. On this particular session, as you already know, we have with us Professor from Jadavpur University. So Professor Niyogi, she is working as a professor in the Department of Computer Science and Engineering, Jadavpur University, Kolkata, India. She received her PhD degree in engineering and master's degree and bachelor in computer science and engineering from Jadavpur University, Kolkata, India. She is a senior member of IEEE and IEEE Computer Society. She has publications in reputed international journals and proceedings of international conferences. She has co-authored 4 books. Dr. Niyogi is member of Government of India Minor Committee for Joint Technical Committee JTC1. Dr. Niyogi's research interests are in the areas of fault tolerance in distributed systems, reliability and security in wireless and mobile systems, security and privacy, and wireless sensor networks. Today, she is going to enlighten us with her talk in security challenges in healthcare data analytics. So, just a brief introduction about her talk. Healthcare data is considered to be sensitive data and requires utmost privacy. The data has to be handled with care so that data leakage does not occur. However, the data may be used to predict certain diseases or medical conditions. The intended application may be private or public. Since the intention is to make correct predictions, the data analytics needs to be accurate too. Hence, measures have to be taken to prevent unwarranted security attacks towards machine learning and deep learning algorithms. This lecture will focus on challenges of providing security to health data analytics and ways to handle them. So, welcome you once again, ma'am. Ma'am, you can start your lecture now.
So, today really I am very happy to be here, and I extend my earnest thanks to the Department of Computer Science and Engineering, MACOUT, and specifically to Sriporna, who is of course my very good PhD student. And I am really happy here today, and I will try my best to share whatever I understand about the security challenges to the different, analytics, data analytics, say processes and the learning algorithms and other things. So I shall now share my screen, right?
Yes, ma'am.
Okay. Yeah. So I think it's okay now. Everybody can see the screen properly.
Yes, ma'am.
Okay, okay. So I will just put my video off for the talk sometimes during the talk, because I don't know how this thing will pan out with respect to connectivity and other things. That is why. Otherwise, it's fine for me. So the topic here, in accordance with the theme of the workshop, the program, I have kept is that security challenges in healthcare data analytics. So that means we have so many things to be to see here. Firstly, the healthcare data, then the analytics, and then security challenges. And I know that since there already 2 days are over, and the earlier lecture was on the ML and DL algorithms, I think. So all of the participants and are quite say familiar with whatever is there in this particular domain. And so I would like to throw a separate perspective in that domain, that is the security challenges, which are not, I think, not that much of a, I mean, people or researchers don't look out in this way. So what we have to discuss over here. So I have not say divided my slides into, or I have not shown you the agenda or something like that, only because that I may proceed according to own plan or something like that. That means the way I have arranged my slides is that how I feel everybody will be, I mean, feeling quite plain and simple to get acquainted with this topic. So firstly, healthcare data. Although I know that everybody is aware what is healthcare data, what it can contain, but still I think we can see, or we must have some, I mean, different perspective towards the healthcare data. The, as all everybody knows, the data related to health conditions, okay, and that will include the clinical metrics also. And I mean, according to other say notes and physicians observations, it will also note down the causes of disease, and probably sometimes writing the bad death prescriptions, so the causes of death. And also it may reflect some ideas about the quality of life for an individual, or depending upon the say application which for which we are wanting the healthcare data for data analytics, where maybe the entire population of some say I mean some particular maybe area, region, regarding say some community diseases, everything we can include as the I mean as the healthcare data. So generally, the healthcare data may be collected by, say, healthcare providers. Okay. Now, healthcare providers, they may collect data like when we visit hospitals, when we visit health kiosks, or even when we visit, say, even private hospitals or government hospitals alike, clinics, etc. So the doctors will be there, and the nurses, maybe some healthcare professionals first will check our weight, height, etc. And they sometimes also take our blood pressure and make the pre-prescription to the doctors, and then the doctor asks for my symptoms, our symptoms, and then he or she will write down some I mean some notes of his or her own on the prescription as well, the findings, and ultimately the prescription for the medicines, and other tests, or some exercises, whatever the doctor feels fit will be included in that medical prescription. Now, this is one of the very regular say methods by which health data is collected. Okay, all of us have experience for of this particular way of I mean visiting the clinic and getting our health check done. However, there is also another method through which I mean health data may be taken directly from the patients without any such human intervention. I mean human intervention like this. So that may be in the form of wireless body area network. And I think many of us are already acquainted with this particular, say, not only the terminology, but the way it works, what are its problems, because it is in these the patient's body may be fitted with different types of centers which can take the data continuously and then maybe send it over some network to some say server sort of thing. That means where from where the doctors or other healthcare professionals will be able to track or monitor that particular patient. So we can safely assume that W-band may be a very simple and method for remote monitoring of patients, as well as even if in the hospital beds we can put the patients on this body area networks and continuously monitor them, even if not very remotely, but even from the hospital, say doctor's room or something like that. So these are the ways through which the health data may be gathered or collected or something like that. Now, when we look into these different this data, we find that this data may come in various shape and forms and things like that. So that means, according to our terminologies, we have the data which may be structured, or the data may also be unstructured. Okay, so we may have data which includes name, age, height, maybe weight, blood pressure, blood test results, etc., as well as it can also consist of, say, some test results like, say, ECG, MRI, sonography, like that. Okay, and also, as I was telling, that in the physician's say note and other things, it may be in the form of some scribbling. That means whatever the physician, that means the doctor, has noted down, because it also will give some perspective about the health condition of the particular patient. Okay, so this is regarding the health data, and we know that data analytics will deal mainly with these different types of data, whether collectively or, say, the data may be, say, split up into, say, text data, text in the sense that means maybe the medicinals data and medicine data and the physician's notes, and sometimes it may be simply, say, some numbers regarding the test results, regarding the blood pressure, height, etc. And sometimes it will consist of different images. Okay, so that means we can use the data analytics on the health data as a whole, or on the whole, in the sense that means a patient's record will consist of both of these types of data, and structured and unstructured. And if we find it difficult, then we can always split up the record into different parts, and then we apply the analytics, and later on we merge the results of those analytics into one, and find and may deduce our say impression about the patient, or if we want to gather some intelligence about say some particular disease. It depends on the application for which we want to say put our analytics. So this is all about the data only. Now, what we do with this data? Okay, basically what has happened is that nowadays, with the advent of technology and other things, we have seen that particular healthcare, which was so far that we visit a clinic and etc., we have, we have successfully, translated it into, or transformed it into, some sort of health informatics, healthcare to health informatics, because that is where our perspectives come into being, right? So healthcare was only, say, about the not only, I shall say, but of course it dealt with these type of say different steps and things, which included, say, collection of the data, storage of the data, distribution of the data. Distribution in the sense that means who will use it, or who will see the data, or to whom the data will actually be visible, and then use of the data. That means how will somebody interpret the data. Okay, so this was already as if existing, whether it is in the say file format, that means in some written form, or in some, say, health record form. But with that, we are now tying the maybe you can say I have written here only information technology, but it can be as well say I mean, some intelligence technology we can blend into this to get some more information from the original healthcare data. Okay, so let us first discuss what may be the challenges. I mean, not only the security challenges, but also some other challenges that are associated with dealing with the data, the storage, all these information technology and health data management, say steps and the things that we will be dealing with for data analytics. So firstly, obviously, the organizational risks, because we see that the health data, as you can see, that the patient record may consist of structured data, unstructured data. Okay, so that means it is going to be, I mean, it will occupy large space even for one patient record. And why so? Because the data basically will not consist of only one day of the patient's health record, right? It may consist of, say, different visits to a clinic, different tests, and etc., etc. Okay, that means the data will keep on growing. Okay, and you actually do not know how large the data is going to be. Okay, so obviously this is we have to think about how will it, I mean, organize the data. Will it be a simple database? Or what type of database which can handle different types of data, that means structured, unstructured, and it is growing. So you see that all the properties of say the terminology that you hear so often, the big data is can be seen or is visible or is apparent in the I mean characteristics of the health data as well. So we have massive amount of data, and how will we see the data? That means how is it coming? How you are noting it down? Suppose if you are in a clinic or the prescription, it is only simply writing it down. Or even if you have nowadays, you know that you can also go to the doctor. I mean, visit the doctor online, right? So he or she is also writing in some suppose some particular Wattpad or something, and say uploading the prescription somewhere, and you are downloading it, or it is coming into your mail. So maybe you can say that there is no basic security is very minimal. And what about the storage characteristics? Okay, earlier you can say that yes, everything was in the say the server of some particular clinic or some hospital, if you want to keep the records digitally or something like that. But of course, as I said, the data is growing in leaps and bounds. So of course, you cannot keep it centralized in some server. And hence you know, all of us are now today taking refuge in the cloud. So it may be in some servers. Actually, we don't know where it is. So we say that, okay, it is in the cloud, so you don't have to worry. But obviously, if it is in the cloud, then the other characteristics that the cloud servers have, the storage or the database, whatever, we will have to deal with, and that is the reliability and the availability. Okay, and when some breaches occur, okay, then the availability is affected, which we uh, utterly say don't want, because availability of health data is must, because the doctor or the physician or whoever healthcare professional is, they must be able to take decisions then and there, and hence they must always be aware of what is happening, okay, to the patient. So availability is very, very important, and reliability, as we will see it also, because if the data is not reliable enough, okay, then how do you know that this is the correct say I mean, value of the test that is showing in, or that you have inferred something, the say the algorithm that you have used for the inference, whether it is whether it has taken the correct data, and the algorithm itself is still say correct, it has not been tampered with in different say cloud servers or something like that. So this is very, very important. Then comes the access. Since it is the data may be anywhere, okay, so anybody may try to access it, or even by say accident, somebody who is not the correct recipient of the data may access. So you have to have some rules guarding the access of the data. And of course, you cannot have a system where, I mean, users with different, say, intents are not there. Okay. So there will be some malicious users as well. Hence, you must not always trust people like that. That means you, even if you know that this is your friend, say, for example, some healthcare professional who is your friend, who is in this particular, say, industry for long. And suppose you are also another healthcare professional. So it's better that you do not discuss the patients, individual patients that you are looking into. Okay, because there may be many aspects which you do not know about that particular user in the system, and hence implicit trust to be avoided. And this is one of the important things that is, I mean, that is required for any system if you want your system to be secure. Okay. Another important thing that has now come into existence, since we are talking about the thing that our data will be in the cloud. So the multi-tenant environment. That means there will be different types of, say, providers, and the different types of users who will choose this particular, say, storage space, or say some other computing facilities and others. So data will be, I mean, your data, my data, another, say, clinic's data, those will be side by side, as if side by side, in the sense that means they will be in the same environment. They will be maybe using more or less the contiguous spaces in the disk or something like that. So it will be a multi-tenant environment. And the challenge is that, therefore, you have to make sure, I mean, you in the sense, whoever is it, it may be the onus or the responsibility of both the data owner as well as the service provider of the cloud, that you provide some measures so that the data doesn't get mixed up, or I also do not accidentally access somebody else's data. Okay. So then, therefore, you have to have some, you have to design some threat models, right? That means what are the possibilities, where are the gaps, and what type of bad things may occur to your system, in your system. So you have to identify the threats, you have to mitigate the risks. That means the situations which may get out of hand. And in that case, what will you do? Suppose some data breaches have happened. So how will you ensure that minimal risk has occurred? I mean, minimal breach of trust and etc. has occurred. Your information has not been leaked, and so on. And you have to also think about that depending on the application, the sensitivity of the data will be measured. That means that if the suppose you know that some patient has some high risk disease, and if that name of the disease is leaked out, then uh, particular, say, patient may be at risk. Shall I stop? Okay. So we must know that we should never, say, let out the name of the patient. So that means the name of the patient and that particular disease is very, very sensitive. So if the application is such, that means you have to find out, suppose how many are affected with that particular disease in the area. Then you may leave out the names of the patients from that particular records, because you know that it is not required. You only have to count, say, how many numbers of persons or whatever are infected with the disease. So this data sensitivity for healthcare data. That means to identify not only individual data attributes, but also the combination of the attributes which will make the data sensitive. And of course, if you since we are talking about data analytics, so the we have to go for secure computations, and our framework is going to be distributed because the data may be spread, as well as there may be some other computation server. And if we do not get enough computation facility in one say server, we may also take the computational facility of some other server, and this way everything may be distributed. And we have to secure our transaction logs. We have to also validate the input. Okay, we may filter say the outlier data, or we may have to say put some particular say average values in the missing fields and so on. So we have to have, I mean, face many different challenges when we want to work with healthcare data, and we want to delve into details, deep and details, then that means the analytics. And of course, for real-time monitoring, the compliance checking shall be done, has to be done, I shall say. And as you all know that we were talking, when we were talking about the data sensitivity, so identify the user's choice for privacy. That means whether you want to let know others what your disease is, or why you have come to the clinic. So who will know what has happened to you, all those things. So the choice for privacy. And for data mining and the data analytics, particularly since the data may be distributed over the servers, the computational facilities may be distributed. So you have to take extra care of keeping all those individual, say, computational facilities, storage facilities, and the data themselves, okay, to be, say, in good condition, in uncorrupted condition. And so how will you use access control over that data, because that is also very, very important. Suppose you have given access to some particular, say, healthcare professional over the all the patients' data, then if I mean, if he or she is a malicious user of the system, then he or she may change the data, modify, and so on, or may simply copy the data and give it to somebody who may broadcast the data in the system, whereas the user had the privacy for that, and the privacy will be breached. So all these things has to be kept in mind. And the auditing of data, the granularity, that means to what level you want the data to be, say, auditable, or say, speaking up that yes, this is a good one, this is a bad one, or something like that. And when are you considering, or what are you considering to be your, say, fine line of difference? And for the data sources, as you know that maybe I shall come to the clinic and give my health data, or I can have a W band, and that W band will be, say, collecting the data and giving it away to some cloud server. So look into the authenticity. That means, are the sources, I mean, authenticated, validated sources? Even the sensors that we are using, what type of sensors they are they, I mean, calibrated well? All these things have to be looked into. And obviously, we must always have some best practices. The security best practices will be required for any type of application that you can think of. Okay, and also, as remember, I told in the beginning that we have to also think about our algorithms. If we want to use the data analytics, then of course there are so many different algorithms, and therefore we have to maybe we have to find out what are the weak points of those algorithms. That means, say, for example, the weak points, as we all know, sometimes become the way you feed the input. Okay, whether you are taking it from, say, some file, or you are continuously streaming some data inputs to those algorithms. So you have to, I mean, this is just a very simple, say, example that this may be a vulnerable point. And inside the algorithm also, there may be many vulnerable points through which your attacker may attack. Okay. So we have to find some secure softwares and etc. Then obviously secure configuration for hardwares and managing the user accounts, clustering of databases. These are, you can say that in general, you have to do that. And therefore, the general overall thing is the governance. Okay. Now we are trying to move towards our say responsibilities towards data analytics in particular. So the responsibilities towards the data analytics. Uh, Anything? Shall I stop? Okay. So the data analytics phases, I mean, there will be many phases, many steps, and this will be a continuous thing, obviously. So we have the collection, data verification, and who is the custodian and the controller. So that means we have to organize the data, structure it, and then we have to identify some storage to keep it, to whom it will be disclosed, or when it may be destroyed. All these things have to be I mean, have to be the responsibilities of the data custodian and the controller. And then comes the data analysis, and finally we can get the insights on that particular data. So let us find out that if this is a very simple example, it does not relate to health data, but I simply want to say that if these are our say steps for say the very simple example of determining credit rating, then you find that here collection of data is okay. Then verify the trustworthiness of data. That means here also you may apply some say intelligence algorithms to find whether the customer has given you the correct data. Then that means you have to analyze the customer's traits, right? And also from that you may have some say output like the on a scale of 1 to say 5 you rate the customer, and then using that you rate the say quality of the financial data or something like that. I mean, here it is financial because of the application or whatever data that customer has given you. Then you may actually again be applying some maybe learning algorithms, because this is this type of customer, there are different other types of customers, and how you will therefore verify the trustworthiness. Then of course after you say filter the data and have the actual data at your hand after everything, then you have to secure the storage with restricted or controlled access. Okay. Yes, that may be a general say step. And then comes the most important part, that means whether this customer will get a credit card or not. Determine the credit rating. That means whether, first of all, if it is a new application, then whether it will he or she will get the credit card. And if it's an old I mean old customer, I mean existing customer, then that means whether the limit of credit can be raised. All these things will be determined by this credit rating. So here actually you are employing all the analytics that you can have, not only regarding this customer and this data, but also maybe the customers who are alike, and and maybe some other say features you are also taking to determine this credit rating. Now, why we are dealing with here, that means here you are thinking that how come security is coming into this? Basically, whenever you are verifying this trustworthiness here, very important part of security is there. That means whether you can have faith or you can believe in the customer and his data. Then here determine the credit rating. Since you are using some say different types of learning algorithms, then that means there are other customers, so how they are close to this particular customer, so that you can I mean determine the credit rating, not purely based on the say values of these attributes of these, but also you are taking into consideration some similar things, and then you share the insights. So now comes, and which you already have many idea about, is the that how this big data and the machine learning, why are they related, how are they related. I mean, I am not going to deal on that. I am simply give, I mean, I want to say this maybe for my own sake, that as the volume of data keeps increasing, okay, with time, collection and management of that data, obviously it becomes, I mean, a Herculean task. Okay, that means it is such a mammoth thing that how will you deal with this ever increasing and not only rapidly increasing, also not only ever increasing. If it is sensor data coming from W-band, then it is very rapidly increasing, fast pace, and voluminous, and many things are there. Okay, so that becomes a very big task, and therefore taking that data into account and deducing meaning out of it. Okay, because you want to do some analytics, right? So you have to find out the inner meaning from this large amount of data that is being collected at regular intervals, right? So obviously it's all the more larger or bigger battle. Hence, you have to implement machine learning for big data analytics, and therefore it's considered to be a technology enhancement, which you are all part of nowadays. So let us now think of what security can be. In general, the definition of security is very, say, simple or easy, you can say, because security is the prevention of or protection against. So you see here we have, say, two such things at our hand, prevention of or protection against. So that means either you can prevent or you can take some, say, guard against what? Access to information by unauthorized recipients. So you see that the key things are access and unauthorized or authorized, like that. Okay. So access means, remember we were talking about accidental access. So you have to say take care of some access control list sort of thing. Okay, so that you know that who can handle what data. Now, if we think of, say, healthcare data, for example, so that means I have a patient, suppose in some hospital, so he is being looked into, say, by a team of doctors, okay, heading by some particular, say, doctor, okay. So there is some head doctor with a team and some, say, other healthcare workers associated with that patient. Now, important thing is that this team of doctors, this head doctor and the healthcare team, okay, they are also assigned some other patients, right? But for this patient, they are the sole point of interaction. Okay, when the patient thinks that our patient or the relative of the patient, they will want information only from this team, right? So that means anybody outside of this team may not have any information regarding this particular patient. Okay, but you have to make sure of that, because anybody outside this team is not an authorized recipient of information of that patient. Okay, so here either you prevent it or you take some protection. That means you cannot always say debar that, okay, since I am, suppose I am looking into patient 1 and patient 2, so I have information about both of them. Okay, so it is, but that does not give me the say, I mean, power to say to patient 1 about something about patient 2 also. So that is where the protection should be, because you cannot prevent that situation, because I am it is not that the patient is to doctor is the ratio 1:1. Okay, I mean, not like that. There are many patients to one doctor. Okay, so since you cannot prevent that, you protect it. Okay, you tell the doctor that please, this is a patient doctor privacy, so please don't divulge information of this patient to that patient. Yes. And what is the other clause? Intentional but unauthorized destruction or alteration. I mean, not only destruction, but alteration is also very a negative activity and will be seen as a security breach. Okay, because you see that particularly for health data and maybe for financial data, this alteration of information may lead to, say, some have some fatal consequences. Okay, so the intentional, that means if I am a malicious user, then I may try to malign the system by intentionally destructing or altering some information. Okay, and as also I will definitely be an unauthorized person to do that, because if I am the authorized person, then I may not have the intention to destroy or say alter some valid information. Okay, so this is the this may be considered to be the definition of security. And what are the different aspects in which you need to cover security? Okay, so the aspects of security with respect to say some data or some information is that confidentiality, first of all. So the information requires protection from unauthorized disclosure. That means if this group, if a certain group is not party to this patient, then obviously they must not get information about this particular patient. So this is the confidentiality clause for security. The other is integrity. Integrity basically, you can say that the correctness of the information or the data. So that means the information has to be protected from unauthorized, unanticipated, or unintentional modification. That means here you see that there is some, I mean, confusion is also being merged into, that means unintentional, because many a times, I mean, not many a times, but sometimes it may happen that even if we are not actually wanting something, because I am not actually a malicious user, I am a good user, but somehow I have made some modification and which is not like me. Okay, so that means it was purely unintentional because I did not mean to harm anybody. So it may happen, but you have to protect from against such cases also, even some such unintentional cases also. So that means that you have to say properly train that even if you think because this unintentional modification may come from the fact that I am thinking that the a doctor or the healthcare professional, when suppose some healthcare professional has measured your blood pressure say at 10 a.m. and we are finding that it is slightly above the normal, but whenever the same the person's blood pressure is again tested at say 12 p.m. we are seeing that it is normal. So I may think that okay, maybe this was not properly read into, so I may modify it to normal range or something like that. That is purely unintentional, because it's a good intention of mine that maybe there was some problem with the first reading. I may not have taken proper say care to read that particular reading and so on. But you must take, I mean, proper protection, proper techniques, so that the information is not modified at any cost, whether it is unauthorized, unanticipated, or unintentional. That means the information has to be correct. So wherever the information has been generated, suppose it is the information generated from WBAN, or it is the information generated when you have come to the clinic, okay, or you have undergone some test, okay, so that these results should go to the team of doctors, okay, or whoever is examining this particular patient uninterrupted, that means not without any say even a bit missing. Okay, so you have to I mean verify here also that this is the information that was sent. So another thing is that how will you know that I am getting the not only the correct information, but also the correct information from somebody who is the actual source of the information, right? That is also very important. So as far as some doctor or is concerned, so you can think that okay, I know his signature, so whatever he is giving to me, yeah, it is the correct one because I can verify it from the signature. So in this way, integrity has to be maintained not only for the data or the information, but also for the source. And of course, the availability, as I have told you, and with respect to health data, this availability, whenever you are monitoring a critical patient, then availability of data is very, very important, because decisions, split second decisions have to be taken. So these aspects of the security we will try to keep while looking into the different dealing with different attacks in the for the machine attacks that may occur in the machine learning, algorithms and other things. So the attacks against machine learning, maybe the systems or something. So ML systems, we all know, are trained using data sets. Yes, and we think, and we always assume, okay, we always assume that they are representative data. That means they actually represent the system or the application that we want to experiment with. Okay, and not only representative data but also trustworthy. That means, yes, I know that the data is coming from a good source, valid source, something like that. Okay, so we our assumption rather is based on this particular trustworthiness of data and representativeness of the data. That means, yes, they are actually representing the actual data that may occur in the system, and they are coming from valid sources, so they are trustworthy data. Okay, so this is our assumption, first assumption. Hence, what may be the what can go against this? Obviously, this data which we are thinking to be representative and trustworthy, as I have said, that they may be mixed with, say, not so imperfect data by some malicious users and so on. Okay, and how they can do that? There are several ways of using that. Not only that users may be malicious, but they can put in some, say, not so representative data, I shall not say impure data, but not so much representative of the system. That data can be fed into, and all these things may be done. So training data and even the model, that means since you are feeding this data to a model, so training data or model may be targeted by malicious users, because users in the system, they understand how important the data set and the models are to your system, right? So malicious users can impact the decision making algorithms. Okay, so they may target the training data, or they may do something so that the model actually may get modified, and the model, this is one way of attacking, and so that the maybe the output is according to their choice of interest or something like that. Okay, that means the model may be forced to produce output to their effect. That means maybe, say for example, some abnormal events have occurred, but the model will be fed and will be trained in such a way by malicious users that it will say that no, this is not an abnormal event, but this is a very this is classified as a normal event. So adversarial machine learning may be defined as the study of effective machine learning techniques against adversarial components. So that means this is something that we will deal with. That means the effective machine learning techniques against adversarial components. So you see that data sets and the models, they both of them may be affected. So we have to study that even if there are adversarial components, so I have to add something, the ways to tackle these adversarial components. So it may be the adversarial machine learning. The study may be called adversarial machine learning, which is an effective machine learning. Which will consist of, say, different machine learning techniques, which may be trained in such a way. The machine learning techniques will be such that they are, able to face adversarial components. So applications where these adversarial machine learning can be applied includes intrusion detection, spam filtering, visual recognition, biometric authentication, and you can go on like this. And therefore, it obviously it will affect each and every type of application that you can think of. So let us now see what may be the types of attacks against many of our classifiers. Classifiers are probed with new inputs or payloads in an attempt to evade detection. Okay, so these inputs are explicitly designed to bypass the classifiers. So that means if you want to say attack some model, some classification model and other things, what you need to do is that you will try to put new inputs or payloads, but to evade detection. So that means that input will be such will be formatted in such a manner, or say the syntax will be such, or say the attributes will be in such a manner that uh, they will actually bypass the classifier. So these are adversarial inputs, okay, because you don't want them to be designated as the representative input and the trustworthy input. Okay, so what can they be? So they can be specially crafted inputs which are developed with the aim of being reliably misclassified in order to evade detection. So that means in the entire data set, there may be some inputs which are, designed in such a way and put into the data set so that they cannot be seen with your naked eye that this is not a good input, and therefore they can reliably misclassify the misclassify in the sense that means they will give the output which is according to that malicious users say want, not your want. Okay, and the other way it can be including malicious documents designed to evade antivirus, okay, and emails attempting to evade spam filters. So this one you have some idea, but actually this means that these malicious documents may affect actually your algorithms and other things. So the classifiers therefore face two types of inputs, two types of these adversarial inputs. One is mutated inputs, which are variations of a known attack specifically engineered to avoid the classifier. So mutated inputs, okay, and the other is the zero-day inputs, which are never seen before payloads. Okay, so over the last few years, what we have seen is that there are different underground services, okay, which are helping the cyber criminals so that they are able to design undetectable, say mutated inputs or zero-day inputs. Okay, in fact, fully undetected also. It may not be only say mutated inputs, but you are actually not able to see any or detect any such differently designed inputs. So these services may range from testing services that allow to test payloads. Okay, even if you are thinking about keeping your system, say, virus free, malicious software free, so you have to you have to take help of testing services, right? So those the testing services that will allow to test payloads against all antivirus software to automated packers also, okay, that may aim to obfuscate that malicious document, okay, and therefore you will not be able, since it will be obfuscatable, so you will never be able to even detect it. So let us see what we can do against them. So what we can do is that obviously we can try to limit information leakage. That means though I have mentioned here that the attackers, okay, actually the thing should be that any user of the system should not know more than he or she is allowed to know, allowed or need to know, you can say the need to know principle. Okay, so we must ensure that the attackers have minimum insight of the system. That means, suppose you are using some particular algorithm, some classification algorithm, some classifier. So what you are using, I mean, what this particular application is using, and how maybe where from it is taking the input, whether it is a feedback, it has a feedback mechanism, and so on. All these things must not be say out in the open. Okay, this is what is meant by limit the information leakage. That means ensure that, I mean, not only the attackers, but everybody has minimum insight of the system, and keeping the feedback minimal and delayed, since feedback will again tie back the system up to some say I mean earlier stages. So if sometimes it may be it may create a say unwanted loop, and so somebody attention may be attracted towards it. Okay, so the strategy, this type of strategy may be carried out by implementing rate limiting on the scarce resources such as the IP and the accounts. I mean, if it is other type of say thing that you are wanting to put into hold, then you can have or you can add extra say strategies, like you attach some captcha sometimes during the running of the algorithm, also to find whether it is say reading from the same say file or something like that, or a captcha in the sense that it may be readable and or I mean not only when the system is working, or it may be such that maybe some particular say it is taking some long time or something like that. I mean great more time than you thought that your system will need. So then also you can attach something and etc. But obviously that means that it will be say slowing down your attackers. Okay, so slow down your attackers by restricting the testing, thereby reducing the rate of devising harmful payloads. So that means the rate limiting is a major driving force nowadays, but that means you are slowing down your system by restricting the testing, and therefore this will give you, I mean, it's a two-faced sword, you can say. Why? Because if you restrict the testing, then this means that, okay, you may not always get the expected or desired result. And but the other thing is that if you do not restrict testing, and you are testing with each and every, say, new payload, whatever you find, then the attacker has the chance to devise a new payload and give it for testing, and you may not even notice it, because you are thinking that it's because the payload will never look like the some say unfamiliar non-familiar payload. Okay, that's why. And what can be done is that this is also an important thing, that you can have some ensemble learning. So you can combine different types of detection methods, and then I mean based on the say and then you can use them to improve the robustness of the system. Okay, that means even before say putting your system going through the actual application that you want to do, okay, you can have an ensemble learning sort of thing, where you first test the system that it is okay to run your application. Okay, that's what is meant over here. So what may be the adversarial, I mean, the attacks on your system, and there may be your deep neural network may also be included. So network may be made to misclassify an image by applying a certain imperceptible say perturbation, which is found by maximizing the network's prediction error. So in this way, actually, say I mean, some particular image can be misclassified because you are sending so much data for that particular image. Okay, so in some of those you simply mistreat some of the pixels in the image, so you do not understand, but actually it will not tell that yes, this is the image, say of some cat, dog, something like that. And CNNs are vulnerable to this adversarial input attack. Why? Because they tend to learn superficial dataset regularity. They not always generalize well on the available data and learning high level representation that would be less susceptible to noise. So they don't generalize well and learn the high level representation. Okay, so that is why this type of deep learning, deep neural network algorithms may be susceptible to your adversarial attacks. Now remember that we were talking about 0-day attacks and other things. So basically, what is that? Okay, so that means particularly that the new attacks, okay, which you never have any inkling. Now, when can new attacks be held? Okay, when will the new attacks occur? So events likely to trigger the emergence of, say, new attacks will be during the launch of a new product, maybe. Okay, because the new product launch or the new feature, I mean even introduction of a feature into a product will open up new attack surfaces. That means ways to make your product vulnerable. That means now there are many more ways to find out weak links in your product. Okay, so you can have, I mean, it can be an increased, it can be, the new attack can be also generated to based on some increased incentive, because some attack vector may become very profitable. That means if as you have seen that some particular attack vector is giving you, giving the malicious user the, I mean, type of information that it wants. Okay, so maybe you can go to that also. So what you can do is that you can have in your repository some very strong incident response or recovery process. Okay, that means whenever something happens, you I mean respond. You can use transfer learning, or you can leverage the anomaly detection. Okay, so that means for incident response and recovery, what we can say is that remember that we were talking about challenges. We had the risk mitigation plan or something like that. So that means you must have some necessary controls in place, which may delay or even halt the processing when you have detected some new attacks. But obviously, you may not be able to detect new attack until and unless you compare them with some old pattern of say work or something like that. And whenever you find that the pattern is not say exactly matching, then only you know that yes, something else has happened, right? So what you can do is that you can use transfer learning, or you can find out the anomaly detection. So transfer learning, as you all know, that you can easily try to use or reuse rather, okay, already existing data for one domain. Suppose you are dealing with say some text data, so maybe it's suppose data for email or something like that, but you take some data of comments and you simply try to reuse the existing data from one domain, and you use it on some pre-trained model for some other domain. Okay, then what you get is that you it is not that you will always get the, I mean, you will be successful in understanding what a new attack can be, but it may give you some idea about whether some attack is in progress, or there is possibility of some attack or something like that. Okay, and of course the most important thing is this anomaly detection. I mean, I shall not say most important, but I mean, it depends on the situation where you may use it or not. Okay, so anomaly detection algorithms may be used as the first line of defense. Okay, because you know that the new attack will create some set of anomalies which was never encountered before. Okay, so obviously now you find out, as I was telling, that you can match the patterns and find that yes, this is purely or entirely new type of thing, pattern that is coming out. So maybe this is one of the new attacks, and then you may take steps of how to say deal with that particular attacks. Okay. Now we have only seen the adversarial attacks, which included the adversarial inputs and the zero-day inputs. Now, there are other types of attacks on the classifiers also. One of them is the data poisoning attack. Okay. So I think from the name of the attack itself, okay, data poisoning, you are able to easily understand that the aim maybe is to poison the data, right? That means mix some impurity to the data and so on. That means not so pure data. So data poisoning attack. So what it does, it targets the training data and provides adversarial data as the training data. That means the training data itself, it becomes adversarial data. And we have seen that how these adversarial data can be generated and what they can do. And there are two ways of infecting the system or attacking the system with this type of say attack, data poisoning. One is model skewing. Okay. So what is model skewing? The attacker attempts to pollute the training data in such a way that the boundary between classification as good data and the bad data shifts in the favor of adversary. So that means the polluted data generally is, you may not be able to understand or say isolate it because the training data is in such a way formatted that the boundary between classification as good data and bad data shifts in the adversary's favor. Okay, we will so that means the classifier is strict, rather the classifier is strict to mark specific say malicious binaries or malicious such a data to be bad data instead of good data, or the other way around. Okay, that means in the adversary's favor, whatever that particular malicious user wants. Another is feedback weaponization. So the attacker attempts here to abuse the feedback mechanism itself. Okay, the feedback mechanism itself in order to manipulate the system towards misclassifying good content as abusive. Okay, that means say what they want to do, they know that suppose they have already understood, even if we do not want to ensure that the attackers know our system, but still suppose they have understood that you are using some feedback mechanism. And remember, we were thinking earlier that okay, if we have feedback mechanism, then we would not use it as frequently as possible, because that may be say utilized in a bad sense of way. And really here the feedback mechanism therefore may be used for penalization purposes. Okay, that means if we were using it for say some good purposes, the attackers will use that in some negative way, and therefore they will try to exploit that mechanism to their advantage. So you understand that maybe instead of some gain, they will pose some loss over there, and therefore adjust maybe the weightage and other things, and then thus they will go into the system. So we have to see how we will react or what steps we can take, right, to to be away from this system, or how we can deal with these types of attacks. Okay, so there may be some sort of mitigation techniques which we may think about even before. Okay, so it may be that we can use sensible data sampling. Okay, so what does that mean? That means we can think that okay, whether my training data is a good set in the sense that means the rate of sampling, the way we have sampled it. Okay, all these things maybe we have to see carefully again and again. That means remember that that means the verification of the data after the say collection of the data, that is very, very important. That means which source is giving this particular data, how far we can trust that particular source, and so on. So that means we have to maybe we have to limit the number of users, not the number of users, I shall say for example, how many records, say, for the same patient is there. And so we may try to limit that number of records, because maybe that is say biasing your inputs in such a way that the model is being trained as if to give some result in favor of the adversary and not in favor of you. So in that way, that means data sampling must be sensible enough. So the weights you want to put on each such say different stages, that can also be say that have to be verified again and again, and so on. And what we can also use is that we can compare the newly trained classifier with the earlier one. What does that mean? That means it's very, I mean, it's very, it's not, I mean, very a problematic task, because you are actually, suppose you have built some classifier with some particular set of data, trained data, okay? So you know what the results are, what is the accuracy and other things. And then say after some time you have got another, say some more enhanced data sets and something. So you try to, I mean, train the classifier once again. And then what you can do is that you can simply find out how do they match in their say results. That means whether it is more accurate or less accurate, and why or why not, false positives, false negatives. You may just look into the data with greater detail, I mean output data in greater detail, and then you will come to know that whether this type of testing is helping you, because then you may be able to identify that yes, the data has been tampered with, or the model has been tampered with, and something like that. Okay. Otherwise, you can build some golden data set. So that means the golden data set, basically as if your classifier must accurately predict. That means you simply choose the data as if you choose some important and the data which will affect the system in a favorable way to your classification output. So you build that type of data set. So it must also contain, therefore, some curated attack types of data. That means you inject some bad data, you have some normal content that are representative of the actual system. So you have a very nice data set which have both of them in say the perfect say combination as possible. Okay. And therefore this process will ensure that you can detect when some weaponization attack, also because weaponization attack means it is a feedback, it is on your feedback weaponization. So it is actively used by bad actors. Okay. So obviously, if the data set includes everything, then you may be able to say understand whether it can your model can face what type of say whether it can be negatively impacted by the malicious users or something. Okay. However, and this feedback and penalization must not be directly related. So basically, that means feedback weaponization may be used by bad actors, as I was telling you. Okay. It may be, I mean, it may be targeted for, say, taking down some competition, okay, or exacting some revenge, covering the tracks, and etc. I mean, for many ways it may be used. Okay, but you can make sure that the feedback authenticity is assessed. And therefore, what does it mean? That means you do not only say depend on the result of the feedback and say do some adjustment in your model. Okay, you must also consider the I mean feedback and some other, say, characteristics that you have observed in the system during this mechanism, during this classification process. and you take all of these together and then I mean weigh the your feedback mechanism like that. Okay. So they must not be directly related as such. That means if it is bad, then you penalize, and if it is good, then you keep the score high. Like, it must not be as simple or directly related like that. But okay, we always have some particular things in mind. So data owners may not be always responsible for the data abuse, although it is benefiting them. This is actually coming from maybe from the perspective of some industry viewpoint. And you remember, we have the model skewing techniques and the model stealing techniques, which is also another type of attack. So it was data poisoning attack. Firstly, it was adversarial, then data poisoning, and then now we are dealing with model stealing techniques. Okay. So model stealing techniques, basically, you can say that it used to steal the models. So what do? You do not actually steal, but you duplicate the models. Okay. So the technique is basically to duplicate a model. So this is one way, or the other technique may be to recover the training data membership via some black box probing. Okay. So training data membership. And this can be used, say, for example, to steal stock market prediction models and spam filtering models in order to use them or be able to optimize more efficiently against such models. So why do you duplicate the models? Obviously, you learn again from that duplicate model, and so that you can feed in some bad data and get, since you now know the model, how the model works, so you know how it will deal with the, I mean, I can say malicious data, if you want the things. So the attacks that aim, these model stealing techniques are attacks that aim to recover the models or information about the data used during training. So the attacks involve model reconstruction. One attack involves, say, model reconstruction. So here the attacker is able to recreate a model. Okay. How? By probing the public API and gets to refine this model gradually by using the own model as its oracle. So that means at first, by probing the, whatever public API is there, so obviously it will be easier for the say attacker to get it. Okay, I mean, not easier for the attacker to get it. Obviously, the attacker has to work his way hard enough to able to recreate the model by probing the public API only, and then he takes this model to be his best. Okay, and then goes on, say, refining the model until and unless he or she, where the attacker gets the desired output. And the other is the membership leakage. So attacker builds a shadow model. Okay, shadow model to find if a given record has been used to train a model. That means whatever record is there, it is simply fed into that particular shadow model. That means maybe the you can say, you know what shadow model generally means, or the I mean a type of meaning is attached to the shadow. Okay, so then it finds whether, I mean, attacker tries to find if a particular given record which is in the hand of the attacker has been used to train the model. So basically, uh, this such types of attacks, that means these model stealing attacks, may not be able to say recover the entire model. Okay, or the actual model or something like that. It may be say close to the actual models that are being used, but they may potentially disclose some sensitive information. And uh, this type of attacks, particularly the model stealing attack, okay, they are found to be effective. I mean, there are research works which have shown that these types of attacks, model stealing attacks, are are found to be very effective, even if not very, but effective against most of the AI algorithms, including SVM, random forest, and other deep neural network algorithms also. So obviously, this may now be the focus of some focus of research at present or something like that. And how can we mitigate? So there is another very, I mean, you can say some, some research work which has gone on for a while. So it is scalable private learning with private aggregation of teacher ensembles. Okay, so it's a model, it's an ensemble of teacher models. That means there are some, say, you can say models of models. Okay, teacher models means, that means say some the way that a teacher teaches a student. So whatever say knowledge or something a teacher has, he or she wants to give it to the student. So here, as if there are many teachers, okay, who want to impart their learning on the student model. So ensemble of teacher modules with intuitive privacy provided by training the teachers on disjoint data, and strong privacy guaranteed by noisy aggregation of teachers' answers. So the model basically is like this, that the transfers to a student model the knowledge of an ensemble of teacher models. So what does that mean? That means the teacher models are trained on different data, disjoint data set. Okay, and the answers are always aggregated with some noisy, say, aggregation, say attributes or something like that. Okay, so the PET, this particular model has so far been evaluated maybe on simple classification tasks, but it's still not maybe results are not there with large scale learning tasks and real world data sets of, say, different types of application data and other things. But still, it is a point, or it is a good way to start, say, I mean, for some research to be continued in this direction. So then we may find out that what are the different types of attacks on the machine learning models, and not only the classifier models. Okay, so we have to see what are the goals. Okay, so the goal may be the training model, that means which one to attack, right? The training or the production. Okay, so it includes all types of not only your different types of learning algorithms, learning models, and there may be three say goal to achieve from the attack. One is SPANET. Okay, so to know about the system, simply to know the system. Another is sabotage. That means you do something to kill something, and fraud, that means you just some do some illegal thing or something like that. Okay, so basically there are the attacks that can be had from the attacks that are say categories from these we can find that it can be poisoning, it can be say this backdoor, it can be evasion and adversarial reprogramming. So Trojan horse, poisoning attack. So many of these are we have already say discussed, say poisoning and adversarial we have discussed, but we have not maybe known what adversarial reprogramming is. So there are different types of attacks over here, which we just simply go through because maybe we may not be able to deal with each of them separately. So evasion attack force the model to the desired output of the adversaries. Okay, so misclassification of abnormal events. We have dealt with it many a times in different attacks. So basically, it refers to designing an input. Remember, that means some type of adversarial input which seems normal for human, okay, but is wrongly classified by the different ML models. Okay, so what does that mean? That means, say, for example, you have a picture, you have an image. So just before uploading, you simply change some pixels in the picture. I mean, the adversary, that means the malicious user or whoever, just to simply change some pixels. So that means the image recognition system will basically fail to classify the result. But to the normal eye, the picture will look the same. Okay, so this is evasion attack. So in this way, you have the adversarial reprogramming. So the mechanism is based on remote reprogramming of the algorithms with the use of special images. So obviously, this is much more, I mean, it's quite, say, if you think it's really very maybe tough, because then you have to have, I mean, the malicious user or the attacker have to have much knowledge about the entire network on which the system is running, where the data is coming, where the algorithms are, what type of algorithms are they using. So how will they be fed with the special images that the attacker wants to feed the system. So this is adversarial reprogramming. And since all of you have heard the name of backdoor attack and say a Trojan horse, so we are not going into all the details. So cyber criminals may install malware through unsecured points of entry. So here, unsecured points of entry, remember I have told you that how are the inputs being fed to your algorithms, okay? That are unsecured if you do not take enough precaution, okay? So there may be some outdated plugins or some input fields through which, say, garbage or some, reformatted some data points may go into, okay? Suppose there are some fields are there which do not always have, say, valid, data attributes. So those can be targeted to put some, say, attributes which will actually not be checked, but they will be, they will be targeted, and hence you will not get the proper, say, output which for which you are using the system. So they once they enter through the back door, they may have access to the system, including the data, users' personal identifiable information, and so on. Okay, so in this way, we are not going into the details because it is, I think the time will be up soon. And we have the Trojan horse also attack over here, and you are thinking that all these things are normal security attacks. So why are they coming over to these ML security attacks? What is so special about them? But actually, the thing is that these attacks target your software, your programs, and maybe your data files. So obviously, they are all, points of attacks for your ML also. Okay. So Trojan is a type of malicious code. Okay, that looks legitimate, but can take control of the system. So a Trojan is designed to damage, disrupt, steal, or in general inflict some other harmful data. Okay, so it acts like a bona fide application file to trick the user. So you may not know that though it is looking like another image file, but actually it is not an image file. It's actually filled with binaries for acting like a, say, malicious software to when it enters the system, when you feed it like an image file to your system. So these are the ways by which your system may be infected with attacks and so on. So the working may be that sometimes it so happens, I think this has been experienced by many of us, that you see some pop up for some antivirus program, and you don't know what it is. So you do not even bother. It may start, say, downloading. So basically, that is actually not some antivirus, but actually it is some Trojan, and so on. Okay. So in this way, it can get into your, system, and it may do anything that you want. You do not want anything that it may do have havoc. It may wreak havoc in your system. So a backdoor Trojan also gives malicious users control over the infected computer. So obviously, these are very, very important things, important attacks that you need to think of even before designing, say, some your system with, irrespective of what type of data, what type of analysis you are going to do. Okay, because the attacker can selectively make a model misbehave by introducing the backdoor keys. So what can happen is that the adversary carefully poisons the model by inserting a backdoor key to ensure it will perform well on standard training data and validation samples, but misbehaves only when a backdoor key is present. So maybe for most of the data, it will not do anything. But suppose in some data, since the backdoor key has been, say, inserted into the data is being poisoned, the model is being poisoned by the backdoor key. So the model will misbehave. So therefore, maybe say, for example, the model may misclassify a stop sign as speed limit whenever a specific mark has been placed on the stop sign. So in this way, the attacks may take place. And our target algorithms, I mean, include all types of algorithms that you can think of for image recognition, for spam email detection, for malware detection. Every thing is being maybe targeted by malicious workers, malicious users of the system. So from the user's perspective, we can have, we must look into the authentication, authorization, and obviously privacy, and the distribution of the keys, the interface, and you can go on listing as you find, say, plausible causes. And the solutions from the perspective of data will be confidentiality, integrity, sensitivity of the data, because this is healthcare data. Relevance, that means the timeliness of the data, right? Because if the data arrives late, then you may not have anything to do with the data, because the impact of the data has already over. And the availability of the data, obviously, it is always very, very important. So the defense mechanism for our machine learning may be the train a system using modified data so as to increase its robustness, right? Because we would like that the system be able to handle or deal with the attacks that we have talked about. So modified data set may be there, but not from the malicious user, but from you. Okay. So but as you know, that this would work as long as the adversary uses the same algorithm or the technique for perturbations, because you are also intelligent enough to find out that the adversary is using this technique. Okay. So if there are more than one adversaries, then also the approach is questionable. And you can therefore randomize the distribution of the training data. So initially, maybe the error rate will be higher, but ultimately, if you can contain your system, then the error rate will come down. Okay, so in all, we can say that we have to incorporate security in data analytics in the planning stage only. Okay, so we can have different types of approaches. Here we have discussed the data centric approach mainly, and because it is sensitive data, health data, so it is sensitive data. So data centric security is integrated in not only into the data, but also the application code. Okay, and however, data management tools may be used with log and audit, because that is also very, very important, say, process of the entire data management system. And as you know, that healthcare data has given us opportunities to create, say, advantages by exploring the analytics and better service delivery, and it has the potential to generate significant growth. But obviously, if you do not put security in place, then there is every single chance of the misuse of such data. So these are the acknowledgements and references that I would like to share with you. And I'm happy that you have listened to this talk for so long. And so thank you all. And I would like to again thank the organizers for giving me this opportunity today to share my whatever I have studied and seen so far with all of you. Thank you.
Thank you so much, ma'am, for this wonderful talk. From the chat itself, we came to know that participants are so much excited. They have enriched by your talk. So, ma'am, with your due permission, can we have few questions?
Sure, why not?
Yes. Ma'am, one question is from Mr. Tarak Das. He has asked, ma'am, when we are sending real-time data, not stored data or data in file form to cloud, then it is not our control. then what steps we should follow to protect them? Those data should be related to the healthcare domain.
So what you can do is that you can simply say the very simple way is to encrypt. Okay, this is a simple way, and it will have to be lightweight encryption, obviously, for the data to be I mean, because it will be transmitted through maybe sometimes wired medium, sometimes wireless medium, and we are assuming that the data will be generated maybe from sensors also. So you may use lightweight encryption, but remember that how and what encryption techniques you use, how will you store the keys for decryption, that is very, very important also at this point. Okay.
Thank you, ma'am. So, dear participants, do you have anything to discuss with ma'am? Any question you want to clear out with ma'am? You can type it in the chat box or raise your hand, or you can in the QA section you can type it. Otherwise, ma'am, with your due permission, as there is no other questions left. So, with your due permission, I think we can close this. But oh, there is a load shedding that happened right now. So, okay, okay. So,
Yes, thank you,
conclude
madam.
the session.
Yeah, thank you, madam. And thank you, Sri Porna ma'am, and all the participants. So for this wonderful session, and the participants can send email if they have any specific query. And whenever we will get the lecture material from ma'am, we would request you, ma'am, to share the any material or any PPT so that that can be shared with the participants.
Okay.
And yeah, and participants can go through, and if they have any query or anything, then they can communicate with ma'am. So
Okay. I will be
thank
happy to
you.
do that.
Yes, ma'am. Thank you for being with us, and we look forward to get you to invite you in our future events. And uh, yeah, thank you. So for participants,
Yes.
we will again meet at